When you learn math in a classroom, what's the first thing you'd say to describe the class? Do you quantitate your learning experience, counting the number of pages of notes you took? Probably not, unless you're super proud of your notes. Most likely, you're talking about the teachers, talking about how awesome their review sheets are, or how confusing their presentation of new material can be. Though some argue differently, teachers and their various teaching methods can make a huge impact on the amount that we learn and how we learn new material, along with the habits we develop when we do our homework. How many of you remember those arithmetic tests in elementary school? Solve 100 multiplication problems in 1 minute and you get a gold star. Why did we do those seemingly pointless tests? We can all hopefully solve those basic equations if we have time to think about it. It turns out those tests were important after all. According to an article titled Math and Memory in Psychology Today, the real payoff comes years later when we're grinding away at our PSATs and SATs. Using images of brains taken with fMRI scanners, it's been scientifically proven that students who know their times tables cold use a completely different part of their brain than those who slacked off and used a calculator all through middle school. The article states that those students with higher math PSAT scores engaged parts of the brain, the left supramarginal gyrus and bilateral anterior cingulate cortex, which have been associated with arithmetic fact retrieval. In contrast, those students with lower math PSAT scores engaged the right intraparietal sulcus, a region involved with processing numerical quantity. In completing the test in the scanner then, students with the higher PSAT scores relied more on their memory of arithmetic facts. The more those neurons are working, the faster you get those problems done, and the faster you finish your PSATs and SATs and everyday math problems. Now go thank your old math teachers. Do you consider yourself a visual learner, audio learner, or both? When it comes to developmental learning, especially with math, the combination of the two can dramatically improve a child's learning experience. In the book Mirroring People by Marco Iacoboni, Iacoboni describes how children learn through mirroring teachers and other influential figures, and used math as a prime example of this phenomenon. According to the book, for math problems, children are more likely to correctly repeat a procedure when the teacher's speech is matched with an appropriate gesture, compared with no gesture at all. Thus, gestures accompanying speech have a dual role of helping the speakers to express their thoughts and helping the listeners and viewers understand what is being said. It follows that mismatching gestures by the teacher get in the way of learning. Indeed, children are less likely to correctly repeat a procedure when the teacher's speech is accompanied by a mismatching gesture, compared with no gesture at all. The example used in the book includes teaching a little girl how to do basic algebra. An equation is written on the board, and as the teacher is talking about it, he points to the wrong part of the equation, showing the girl to add up all of the numbers as if they were on one side, while telling her the right way to do it. Though the answer of the question is achieved, the girl will later try to do a similar problem, and will most likely start adding all of the numbers as if they were on one side of the equation, therefore getting the wrong answer without the teacher's assistance because her visual and audio memory are mismatched. Don't worry, she'll eventually learn the concept, but this kind of mimicry and combination of visual and audio learning can be imperative in understanding more complex concepts. So with all of those facts, how can we as older people apply this to math class or any class? Children show signs of having a larger quantity of something called mirror neurons, which are responsible for learning through mimicry. They allow children to catch on to concepts faster, which, by the way, is why it's better to start learning foreign languages at younger ages. We still have a lot as we grow up, which means that mimicry can still play a very important role in the learning process. Though it's tempting to think watching those tutorials online the night before a test is going to help you absorb concepts in minutes, what will ultimately set your mind at ease is practice after those tutorials, or even better, after your actual class. In 2007, Time magazine published an article titled The Brain: How the Brain Rewires Itself, describing an experiment done on learning through physical versus mental practice. Two groups of people were asked to learn basic piano playing skills. One of the groups got to practice playing on an actual piano, while the other group sat in front of a piano, only able to imagine using their fingers to make some music. The results were revolutionary. The article states, for what the TMS revealed was that the region of motor cortex that controls the piano-playing fingers also expanded in the brains of volunteers who imagined playing the music, just as it had in those who actually played it. In other words, the group of people who had never played a piano before in their life had literally grown the area of their brain responsible for controlling the movement required to play the piano. So in some senses, I guess you could argue that those late-night tutorials can help if you keep visualizing those formulas and theorems. In the long run, however, the two groups of would-be pianists in the experiment grew farther and farther apart, with the group physically practicing every day excelling, while the other group lagged behind. Practice is one of the only truly effective ways to really ingrain concepts in your head and store them into long-term memory. If a teacher really wanted to check to see if their students were diligently doing their homework in a class they took, all he would need to do is wait a few years. Chances are, the students doing the most homework or extra practice will probably remember the most today, even if they didn't necessarily excel in the class before. On the surface, it could probably seem like I'm telling you to do your homework more often, and I'm not, because it's not my place to do that. But this is not a science that only applies to math class or school. People will probably tell you all your life to keep doing what you love, and it might get repetitive, but they're right. Not only will you feel better about yourself doing something that you enjoy, you'll be growing the parts of your brain associated with what you're physically doing and what you're thinking about. Now that's the power of thought. Hello. I hope you enjoyed this presentation. I don't know what to say. I'm talking to myself.